Good morning everyone. Myself Dr. Inderjit Kaur, Associate Professor in the Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. So, after covering the different testing objectives and types of testing, we will be moving on to the strategies that are to be opted by the testing, what are the drivers and stubs used in testing, and a kind of testing, that is structural testing, also called white box testing. So, starting from the testing strategies, as testing strategy, it describes the testing portion of SDLC. We are aware of entire SDLC. It starts with requirements, then we move on towards the design. After that we code it and then we test it and then we maintain it, and after testing we can deliver it to the customer. So, strategy of testing, it is basically focusing on the testing portion, this one. It can be of any kind. So, it integrates the design of software test cases into the organized steps for the successful software development. We want our product should be successfully delivered, it should be error free. So, for that we have to test our code written at the unit testing level, then we have to integrate it, then we have to think whether it will be accepted, means the customer is also getting involved in this. So, testing strategy means it is integrating the entire steps what we can approach, so that our product is successfully delivered. Then strategy means we are giving a roadmap when and how much effort we have to give, when and how much time we have to give to any module, when and how much resources are required in doing the testing. As I said, I will be starting from the unit testing. So, entire separately written modules, they should be first tested, then their integration is going to happen, whether in doing integration are there any bugs coming. So, if they are coming, we have to remove them, and after then user is coming into the picture, so that acceptance testing comes. So, in that way we will be giving. So, strategy, it is giving us the roadmap, then it incorporates the planning, how my testing planning is going. Likewise, we started with requirement gathering, then we fixed on to one single sheet, that was our SRS. So, as on SRS was fixed, we move on to the design document. After that design document, we have come to know that these should be the functions defined, then we started coding as per these functions. Now, the next thing comes, what code we have written, is that error free or are they correct, then what was the need of that code and how it is behaving in integrating, means two modules together correctly running or no. So, this kind of planning is required. Then on which kind of set of inputs is it working correctly, that is the test cases. So, selecting proper test cases is again a task. Then whether these test cases they are executing successfully, or what is their test cases results and how they are being evaluated, that all comes under testing strategy. So, our objective for doing the testing strategy, it is to optimize the cost of testing versus cost of defects. Here I will be aware of all the cost that will be coming, how much time I will be spending in testing, how much effort I will be doing in testing. So, accordingly is it worth to spend, or the cost that I have decided at the time of agreement between the customer and the team, is that going that way or my cost is getting increased. So, testing strategy, it focuses how I am going to optimize my effort, cost and time done during testing, or I am doing more, or there are errors more and user does not want that. Then next comes, what are the different characteristics of these testing strategies. Characteristics means the software team, it should conduct effective formal technical reviews. Means the entire team, it should be involved in more knowing more and more things, features about the software. That can be possible by conducting the technical reviews, gathering information from every member of the development team. Then it starts with the component level, the entire separate component that are being designed, they are being tested first, and then we move on to the integration of the software. The entire system is tested after the individual modules are successfully tested. They are giving the correct output, their test cases written, they are successfully verified. Then we can opt for different testing techniques at different points in different time. As I said ki at the initial levels we will be doing with unit testing, after that we will be switching to the integration testing. For doing unit testing we can opt this kind of testing, we can at the time of integration we may do these kind of testing, and then acceptance testing, again the kind of acceptance testing as we have discussed in the previous lecture, we may take that either it can be alpha, it can be beta, or it can be UAT and all. Then this testing, it is conducted by, some testings will be conducted by developers, such as the unit testing, it will be done by the developers who is writing the code, he will be doing the testing, and some testing they will be independently tested by the testing teams. And then acceptance testing, it involves both the development team also and the user also, to which we are going to deliver the product. That is, some testing involves the development and some involves the independent testing teams. Then comes the question of debugging. Testing and debugging, they are different activities, but debugging, it should be accommodated in any testing strategy. Suppose I am testing my separate module written, line by line I am checking it, that is my debugging, ki whether it is giving the correct result. Suppose this is the lines of code that I have written for any software, x and y I have defined, and then I am doing x plus y for I is equal to 1 to 10. So, whether it is giving correct result, checking for various kind of inputs, that is debugging. Debugging tells us ki at which line of code I am getting the incorrect result, and then I can go for the change and then it can be corrected further. Then comes ki what is verification and what is validation, that is the concept of V and V. We start with verification. Verification means, are we building the product right? Whether the software that is going to build, it is right or wrong, the decision, that is, it can be done by doing the set of activities that will ensure that the software, it correctly implements the specific function or algorithm. Means the algorithm, the code that I am going to write is correct or no, verify that. Checking that ki my inserted algorithm, my written function is behaving correct or no, that is my verification. Then comes the validation. Are we building the right product? That is the set of activities that ensures that the software has been built, it is meeting to user requirements. That is, here it is doing the system testing, it is just validating that our written software is giving correct result as per my SRS written. That SRS was MOU kind of thing that was undersigned between the customer and the design team, software team. So, is it validating, means are we building the right product? The strategy that we have selected right, that comes under verification, and the product that we have built right or no, that comes under validation. So, how can we know that ki whether we are right or wrong? That comes only once we have said that once we have compared it with our SRS. Then for the designing the conventional software, there are various strategies that are being followed. As I said ki we start with system engineering, then we move on to the requirement gathering. We standardized some requirements. Now, these requirements are fixed. I have to go according to that. Now, as per these requirements, we will be making a design, flow chart, data design. That is, I will prepare here a design document. Every team of the software person, they have to follow this design document. And as per this design document, we will start coding. The inner modules, they will be coded first, the sub functions, they will be designed first, then we will be going on to the upper levels. So, that is, I can say ki I have started from the system engineering and I have moved on to the coding. That is, this is my abstract to concrete way I am going, and when I am moving on to the coding now. So, we said ki I have written one sub function code. Next target is to check ki whether this written code is right or wrong, that is doing unit testing of this code written. So, likewise one code is tested, suppose there are 10 functions being defined. As per this design document, 10 functions are to be prepared. So, these 10 functions independently will be written and independently they will be tested. So, here my unit testing comes into the picture. After doing this unit testing for the 10 modules that I have written, now my next target is to do the integration for these 10. These 10, suppose one module, 2 module, 3 module, they together they are being called in the main function, and then after some time 7, 8, 9, 10 modules they are called in the main functions. So, when they are being called for different set of values, are they behaving properly? That is my integration. After doing this integration, I will do the validation ki whether are they giving correct result as per my SRS or no, because now I will validate them as per my standard requirements. Are they matching or no? Then after they are being matched, I will produce a system and I will do the system testing. So, that means while doing testing, I am starting from the narrow level, I am starting from the unit testing and I am making my vision broader. So, narrow to broader I am doing in the testing, and the reverse approach from everything to what I specific need is, that is doing designing. So, reverse approach. So, once I am doing the unit testing, that means what I am doing? I am making a specific path in a component control structure ki how my code will behave for this particular set of inputs. That is, I am specifying path in a component control structure, so that I can ensure ki it is maximum errors are detected and I have covered maximum coverage. I have started, I have checked it for various set of inputs and it is behaving correctly. These things I am doing in unit testing. Next, when these 10 modules they are being integrated, that means when I am doing integration, that means I am focusing here on every kind of input and output, and for every input and output, are my components working together properly or no? That is being checked in this. Then third kind is my validation testing. Validation, as I said, I will be checking here ki whether my written software is meeting as per the requirements written in the SRS, means is my software behaving properly, functional, behavioral and performance, is it giving as per my SRS written or no? So, if there is answer is no in some manner, So, it will be changed accordingly and then integration will again happen and they will be unit tested again. Then moving on to the system testing. System testing means I will be verifying that all the system elements they work together properly to achieve the system performance. Means in every respect is my designed software behaving properly or no. Then setting the targets in case of unit testing. So, unit testing test cases targets they basically focuses on the internal processing logic. As I said ki I will be starting with the unit testing means my sub module, suppose addition module, is it working properly or no, that means I am going to check my internal processing logic or I am going to check ki whether the taken data structure is giving me the correct result or no. So, that or some in critical issues why my cyclomatic complexity is coming high. So, it can be checked in various ways. Cyclomatic complexity I will discuss it in the later on stages. It is the complexity, it is a just kind of measure number of independent paths the software can take plus 1. How well my software is behaving on boundaries, how well my software is behaving on all kind of inputs that I have to take, that is defining the cyclomatic complexity. It was being given by Maccabe's. So, first I will be focusing on the module interface, means how well the information flows in and out of the module. Then I have to focus ki what kind of data structure I have opted. If they are being defined locally, that means how they are maintaining the integrity when they are being called in the main function. Then third thing, how my function written they are behaving in kind of boundary situations. Are they behaving properly or are they giving incorrect result? Suppose I have defined a variable that can take value from 0 to 10. So, what is the behavior of my module at 0, at -1 or at 10 or 11? Fine. So, that will be checking at the boundary conditions. Then independent paths, all the statements in the module are they executed once or this path has never been followed in entire software execution. Then how I am going to handle the errors, that is how well my algorithm it is responding correctly to the error conditions. Is it coming out or is goes infinite loop and start running and then I have to separately escape it. Then the use of test drivers and stubs in case of doing unit testing. If all the modules written they start behaving correctly in every respect, then half of the task is done. That means I know ki whatever module I have written, their functions works very well during their input and at boundary stages. In robust situation, in worst situations, how well my program is going to behave. So, see, these are my suppose this is my function that I have written. Now, several functions they are being written and they will be incorporated, they will be called in the main function. But sometime it may be the situation ki main function is not being defined at all. So, when this is the case, I will be using the driver. So, driver will be a main program, a dummy main program that accepts the test case data and it passes this data to the different functions that are to be tested for their results. So, here suppose this is the module, this is the function that I have written, this is to be checked. So, when it is being checked, when it is being called in the main program and that main program is not being defined, I need to define a driver. As I said ki it is a interface, it is a main program, dummy program that is being defined. So, in this I will be defining the local data structure and I will checking it for boundary conditions, for independent path and for error handling that we have discussed in the previous slide. As I said ki if this module it requires some things that is again not being defined, so I will be creating stubs. So, stubs is it will be replacing the module that is not being defined. If it is called by any module and that is not being defined, that is my stub. So, for this module I have written the test cases. Then the next thing, structural testing. Structural testing, it is also known as my white box testing. It tells me to examine the internal structure of my program, ki how what is the internal structure of my program, how not focusing on the logic, how modules are being defined, how many modules are there. So, it requires thorough knowledge about the internal structure and software for design the test cases. If I am aware of the internal logic of the program, I can tell what can be the expected result of my software. There are various criteria for doing the structural testing. One of them is path testing. This path testing can be achieved by either drawing the flow graph or by drawing the DD graph, or we can calculate the cyclomatic complexity for structural testing. We can draw the various graph matrices and we can do the mutation testing. So, we will be focusing on all of these criteria one by one. Let us start with the path testing. As I said, path testing it is kind of structured software testing approach, and this methodology it requires to design the test cases that covers all the linearly independent path. That means all the independent paths they will be tested. I will be drawing the CFG and according to that CFG I will draw the DD graph, and in that DD graph I will check ki whether all the paths for the software has been taken or no. So, two types of graphs they are being designed when I am doing the path testing. One is my CFG, that is control flow graph, and after drawing the CFG I will make a DD graph. DD graph means decision to decision. All the linearly things they will be taken as one node. So, the steps are, first I will be design the control flow graph. After designing the control flow graph, I will be writing the DD flow graph and then I will be calculating the cyclomatic complexity. Once I am done with the cyclomatic complexity, now I am in a situation to know the how many test set paths are there, how many independent paths that my program can follow, and every program is tested as per this paths. This is the control flow graph, that means my written program is converted into the flow graph that are being represented by the codes into nodes, regions and edges. All the linear sequence statements they are represented like this. If there is any if then else structure, I will take ki if, then and else. This is for then and this is for else. After that they are again being merged. This is while. If while true, I will do this till the while goes. If while goes out, then I will go this. If this is again repeat until loop, and this is the switch 1 to n situation case. So, this is I will be drawing the control flow graph. I will be taking one example. Suppose this is the code written in my program. If A is 10, then if B is equal to C, then A is equal to B, else A is C, and if this is outer if loop end, and then I am going to print my ABC. Now, suppose I have to draw the CFG for that. As I said ki at 1 I am taking a decision, either I will be going to 1 to 2 or I will be going to 1 to 6. So, 1 to 2 there is one path and 1 to 6 there is another path. Then at 2 again there is again if statement. So, if statement, either I will be going to then 3 or I will be going to else 4. So, again I will be meeting at 5 and if. From 5 to 6 I am again moving to outer end and if, and then I am going to print ABC. So, for every program now I can write my CFG, I can draw. So, now let us draw the decision to decision path. Now, the CFG, it can be broken into various decision to decision paths and then it can be collapsed to individual nodes. So, I am taking here the triangle problem. The program is to check ki whether the input given x, y, z, suppose I am giving the 3 inputs, suppose what kind of triangle it is. Either it is not a triangle case, either it is equilateral triangle if all the sides are equal, or either it is isosceles triangle or the scalene triangle. So, I have written the algorithm for that comprises of 10 steps. First step, input the 3 sides x, y, z, they all should be 0 greater than 0, and then here I am checking ki if x is greater than or equal to y plus z, or y is greater than equal to x plus z, or z is greater than x plus y, then I will be giving the output not a triangle, it cannot be a triangle. Else if x is equal to y and x is equal to z, then equilateral triangle. Else if this is the case, then isosceles triangle, else scalene triangle and return output. So, these are the steps written for the triangle problem that can 4 situations can happen as per this algorithm. So, let us draw the decision to decision. Here I have taken one step. So, in the CFG, in the code there can be multiple n sequential statements, they will be reduced to 1, but here I will be taking only 1. So, I will be starting from 1 input, then from 1 I am moving on to 2. So, at 2 there is a if statement that says ki either go to 3 or else if 4. So, 3 2, if there is a case of not a triangle case, I will simply AND 10. So, at 4 again there is a if then else loop, either I will be moving on to the 5, either I will be moving on to the 6. If I am at 5, then my things are over, I will be moving on to 10. If I am at 6, again there is a if, so I am taking the decision 7 and then I am moving on to the 8. 7 to I will be moving on to the 10. From 8 again there is a sequential statements 9 and from 10. So, this way I am going to draw the decision DD graph for any kind of program. As I have drawn it from the algorithm, so I have not taken the sequential statements. For if for first statement, suppose there are 2 to 3 things defined, so those they will be sequential statements. So, kindly take them as a one statement in your DD graph. So, now from this DD graph I will be calculating the cyclomatic complexity. This cyclomatic complexity, it is also known as the structural complexity, it is giving us the complexity of my program. So, it defines the number of linear independent path that my program can follow. There are 3 methods for calculating, for defining this cyclomatic complexity. It was being defined by Maccabees. First method says, suppose there is a G control graph that I have drawn. So, for the complexity it can be computed as E minus n plus 2p, where E is the number of edges, n is the number of nodes in CFG and p is the paths. Then method 2 says it is number of bounded areas plus 1, and third method says कि I have to define it as n plus 1, where n is defined as the decision statements. For any DD graph, if whatever if nodes are there, count that plus 1, that is third method. How many bounded areas, covered areas are coming, plus 1, second method, and calculating it from the edges and nodes, that is my first method. So, in the program that I have drawn in this slide, here I can see there are 12 nodes and 10 edges, 12 edges and 10 nodes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, and 1 to 10 numbered nodes 10. So, I have here written edges is 10, nodes is 10, edges is 12, nodes is 10, connected regions they are taken as 1. So, from VG it is being calculated as 12 minus 10 plus 2, that is 4 it is coming. We can calculate it from the second and third method. So, the paths that my program will follow, that will be either 1, 2, 3, 10, we can see it. Either my program will follow this 1, 2, 3, 10, one number. Either my program will follow 1, 2, 4, 5, 10, this is the second. Then 1, 2, 4, 6, 7, 10, third. 1, 2, 4, 6, 8, 9, 10, that is my fourth. So, these are the four paths that my program can follow is written P1, P2, P3, P4. Now, the next task is to test these P1, P2, P3 or P4 test cases. Then the fourth method is graph matrix. Graph matrix is a data structure that will be helping us to do the automation for path testing and mutation testing. Here I am inserting the errors from purposely, and then my that error inserted code is known as the mutant, and that mutant of the program is test cases for that mutants, they are being checked, and then I am defining the test cases so that I can detect the error. So, this was all about the testing strategies and the structural testing and the methods that I have discussed, the various for doing the structural testing. Thank you.